The next concept here we want to consider is lowest common multiple, called LCM. What do we mean by lowest common multiple? Lowest common multiple is otherwise called the first common multiple. Take for instance, the question may say, find the first common multiple of 2, 3, and 4. How do we go about this? Let's start by listing the multiple of 2. Multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, and so forth. Let's come to 3. Multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, and so forth. Multiples of 4. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, and so forth. And the questions ask for the first multiple, the first common multiple of 2, 3, and 4. Anytime you hear the word first common multiple, it simply refers to lowest common multiple, LCM. And when you hear LCM as well, lowest common multiple, let your mind quickly go to the first common multiple. That is what the other name we call it. Lowest common multiple is the same thing as the first common multiple. Now, what is the lowest common multiple of 2, 3, and 4? LCM of 2, 3, and 4 is, let's check it up together. What is the common multiple to the 3 numbers? To 2, to 3, to 4. What is common to them? What is the multiple that is common to them? You can see 2 is not common to them. 4 is not common. 4 is in 2. 4 is a multiple of 2. It's also a multiple of 4, but not a multiple of 3. 6 is not. 8 is not. 10 is not. But you can see 12 is common to them all. Because it is the first common multiple, so we call it the lowest common multiple, because it's the first. By the time we realize the second common multiple, the second one will be higher than the 12. That's why we call that 12 the lowest among the common multiples. Now, answer is 12. LCM of 2, 3, and 4 is 12. What if the question has us to find the second common multiple of 2, 3, and 4? The second. How do you go about it? Once you know the first, don't stress yourself anymore. You just multiply the first by 2. It will give you the exact answer for the second common multiple. If you are asked to find the third common multiple, just multiply the first common multiple by 3. Whatever you get will be the exact answer, which is the third common multiple. Do you understand? I'm introducing this to you in this approach. We will still go deeper. So, let's see, second common multiple, second common multiple, multiple of 2, 3, and 4 is, you just go for the LCM, which is 2, multiply it by 2, you have 12. I mean, the LCM, which is 12, multiply it by 2, so you get 24. So 24 is the second common multiples of 2, 3, and 4. And let's take it up truly in the list. You can see 14 is not common, 16 is not common to them all, 18 is not common to them, 20 is not common to them, 22 is not common to them, 24 is common to them. Look at it. It's the second number that is common to them among the multiples of them all. So 24 is the second common multiple of 2, 3, and 4. You can see. But see the shortcut of getting it without going through the long list. So even if you are to find the third common multiples of 2, 3, and 4, what do you have to do? Just take the first common multiple, which is the LCM, 12. Use 3 to multiply it, you get 36. So 36 will be the third common multiple of 2, 3, and 4. And let's check it up in the list on the board. You can see 26 is not common to them, 28 is not common to them, 30 is not common to them, 32 is not common to them, 34 is not common to them, but 36 is common to them. You can see 36 is common to them, and it's the third one. It is the third number that is common to them. So that's why we call it the third common multiple of 2, 3, and 4. 12 is the first. 24 is the second. 36 is the third. The third common multiple of 2, 3, and 4. So that is it by way of introduction. So we are going into different examples that will widen your horizon in these concepts. Let's consider example 1 under this lowest common multiple. Example 1. Find the LCM of 36, 45, and 60. There are two ways of finding LCM actually. We use long division method. Number 2, we use product of prime factors method. Product of prime factors method. So I'll be using the two methods available for each example for proper understanding. To find the LCM of 36, 45, and 60, what do? Using long division method first, we take the numbers involved here, 45, 60. So we divide all of them with all the possible factors that could divide them. But there is a difference between the LCM and HCF, you will see as we go. 2 goes in 36 in 18 times. 2 divide 36, we have 18. 2 cannot divide 45, so we repeat 45. 2 divide 60, 30. So 2 again can divide 18 to give us 9. 2 cannot divide 45, so we repeat 45. 2 can divide 30, we have 15. 2 can no longer go or divide any of them, so we move to 3. The next prime factor. 3 in 9 is 3. 3 in 45 is 15. 3 in 15 gives 5. 3 again can divide 3 to have 1. 3 in 15 is 5. 3 can no longer divide 5, so we repeat the 5. The next prime factor is 5. 5 in 1, we repeat the 1. 5 in 5, 1. 5 in 5, 1. That's the end. Therefore, LCM of 36, 45, and 60 is 2 times 2 times 3 times 3 times 5, which is 2 times 5 is 10. 2 times 3 is 6. 6 times 3 is 18. 18 times 10, that is 180. That is the LCM. And if we wish to leave it in index form, we say, or 2 raised to power 2 times 3 raised to power 2 times 5. That is it. Let's consider the same question using another method. That is what we call product of prime factors method. So, in that method, we express each number as a product of their prime factors in index form. So 36 is 36, 2 in 36, 18, 2 in 18, 9, 3, 3, 3, 1. So 36 is 2 raised to power 2 times 3 raised to power 2. 45. 45 will be 3 goes there, 15, 3, 5, 5, 1. So 45 is 3 raised to power 2 times 5. Next is 60. 60 is 2 in 60 is 30. 2 again in 30, that's 15. 3 in 15, 5. 5 in 5, 1. So 60 is 2 raised to power 2 times 3 times 5. The logic here is simple, but you have to be very meticulous. LCM, which is the lowest common multiple in this regard, is obtained by taking the product of all the available prime factors in the 3 numbers. But you take all the available prime factors in their highest power. You can see it is the opposite of lowest. We are considering lowest common multiple, lowest. So when you come here, having expressed each number as a product of prime factors in index form, take every prime factor in its highest power. This is what I mean. We have prime factor 2 available in 36 and in 60. We have prime factor 3 available in 36, in 45, even in 60. We have prime factor 5 available in 45 and in 60. So we take every prime factor available in their highest power. Let's take prime factor 2 first. Prime factor 2 is available in 36, is available in 60. In 36, it is the highest power we have is 2. In 60, we have power 2 as well. So, since they are of equal power, take any one. You have 2 raised to power 2 times. So, let's go for prime factor 3. Prime factor 3 in 60 is 3 raised to power 1. That is, when it seems there is no power on something, there is power 1 there. So 3 raised to power 1. Prime factor 3 in 45 is 3 raised to power 2. In 36 is 3 raised to power 2. And we have to take every prime factor in its highest power. So we take 3 raised to power 2 times, we go for prime factor 5. We take it in its highest power, but unfortunately it is not available at all in 36. In 45 and 60, we have them in equal power. So we are free to take any one. So 5 raised to power 1. This is the LCM, which is exactly the same as the first approach. You can see 2 raised to power 2 times 3 raised to power 2 times 5. And if you so wish to leave it in whole number, you have it as 180 when you dissolve the power. And that is it. Let's consider example 2. Find the LCM of 252, 567, and 378, leaving your answer in index form. I will solve the question using the 2 methods available. Method number 1, the long division method, 252 5, 6, 7, and 3, 7, 8. 2 goes in this. 2 divides this. 1, 2, and 6. You can see. 2 in this. 2 cannot divide this, you can see. So you repeat it. 5, 6, 7. This can be divided by 2. This is 1. It remains 1 in 17, 8. It remains 1 in 18, is 9. 2 can still go in this. We have 6, 3. 2 cannot go here, you repeat it. 2 cannot go here, we repeat it. 2 can no longer divide any of them, so we take 3 as the next prime factor. 3 in 6, that's 2. In 3 is 1. 3 in 5, 1. Remains 2. In 26, that is 8. Because 3 times 8 is 24. It still remains 2. That 2 with 7 is 27. 3 in 27, that is 9. So, coming to this, 3 in 18, that is 6. In 9, 3. 3 again can divide 21, giving us 7. 3 in 18, 6. In 9, 3. 3 in 6, 2. In 3, 1. 3 can still divide, but not 7, so we repeat the 7. 3 in 6 is 2. In 3, 1. 3 in 21, 7. 3 can still go in something there. We repeat the 7. 3 in 21, 7. We repeat the 7. So 7 now can go in 7 one time. One time in this 7, one time in this 7. Therefore, LCM is equal to, that is, the lowest common multiple of 252, 567, and 378 is 2 raised to power 2 times 3 is in how many places? 1, 2, 3, 4. 3 raised to power 4 times 7. And that is the answer, because the question says in index form. So that is it. Let's consider this same question using the second method, which is the method of product of prime factors in index form. Let's manage this little space. In that method, I put all here for you to demarcate them. So we put 252. We express 252 in index form. We break them into index form. That is, we write 252 as a product of its prime factors. Do we understand? So this will be, if you take, there's no space, so much space here. If you divide this on the table of long division, you have 2 raised to power 2 times 3 raised to power 2, also times 7. Times 7. That should be correct. 2 raised to power 2 times 3 raised to power 2 times 7. And the second number, which is 567, should be, maybe we should manage this. 567 should be, what goes in this? 3. 3 goes here. 3 here. 1. Remains 2. That is 3 in 26. That is 8. It remains 2. In 27, that is 9. 3 can still go. 3 in 18, 6. In 9, 3. 3 in 6, 2. In 3, 1. 3 in 21, that's 7. 7 here, 1. Yeah. This is 3 raised to power 4 times 7. 3 raised to power 4 times 7. I decide to do that in your presence so that you will not be wondering where did Mr. Idowu get this one. He didn't explain to me now. So you can see there's nothing. That is what you need to do when you want to extract your own 2. Also, the last number, 378. You break this also into this, forming your own table as well. And if you do it correctly, you will get 2 times 3 raised to power 3 times 7 to save our time. If you do it correctly, like this, breaking this to 378, writing it as a product of its prime factor in index form, you will get this if you are correct. So now, to determine the LCM in this regard, what do? Don't forget, having expressed each number as a product of their prime factors in index form, now find the product of every prime factor available in their highest power. 2 as a prime factor is available. 3 is available as a prime factor. 7 is available as a prime factor. But we have 2 raised to power 2 in the first number, 2 raised to power 1 in the last number. Meanwhile, 2 is not existing in the second number. So we are going to take the 2 in its highest power, which is 2 raised to power 2, right? 2 raised to power 2 times. Now, 3 as a factor, as a prime factor, exists in the last number here as 3 raised to power 3. It exists in the second number, the middle number here, as 3 raised to power 4. It exists in the first number as 3 raised to power 2. But we are to take it in its highest power. That is, we are to take 3 raised to power 4. 3 raised to power 4 times 7 also exists. But 7 across the 3 numbers maintains the same power, power 1. So we have 7, and that is it. Looking at comparing our answer in this approach with our answer in the previous approach, you can see there is no difference. The LCM here is 2 raised to power 2 times 3 raised to power 4 times 7. Also, the LCM in that is the same thing, and that is it. Let me give you the last example I have for you in this. Let's consider example 3. Find the LCM of 2 times 2 times 3 times 7, comma, 2 times 3 times 3 times 3 times 5, and 3 times 5 times 7 times 7. You can see this one is given to you already in product of a prime factor approach. So you cannot say you want to use long division in this question, because you can see that the question is even given to you as a product of prime factor. One thing is needful here. What is that? You write each of them, the 2 times 2 times 3 times 7, rewrite it as 2 raised to power 2 times 3 times 7 in index form. The next one, which is 2 times 3 times 3 times 3 times 5. Rewrite it as 2 times 3 raised to power 3 times 5. And lastly, 3 times 5 times 7 times 7. Rewrite it as 3 times 5 times 7 raised to power 2 for easy access or easy application of the method I taught you. LCM in this regard will be equal to taking the product of every available prime factor in their highest power. Highest, opposite of lowest, is highest. So taking the available prime factors in their highest power. Taking prime factor 2 in its highest power. We have 2 raised to power 1 here, 2 raised to power 2 here. 2 does not even exist here as a factor. So we write 2 raised to power 2, the one with the highest power, times, we go for 3, 3 raised to power 1 here, 3 raised to power 3 here, 3 raised to power 1 here. We take the one with the highest power, 3 raised to power 3, times 5 raised to power 1, 5 raised to power 1. 5 does not exist in this, so we take 5. At least that's what we have. 7 raised to power 2 here, 7 raised to power 1 here. 7 does not exist in the middle number here, so we go for the one with the highest power, 7 raised to power 2. And this is the answer. So anytime question is posed to you like this, don't be scared. Only be careful. If it is not expressed in index form, try to express it in index form so you can apply the method I teach you. That is it.